Everyone, welcome back to Life Technologies channel and thank you for watching. So today we'll be doing our part 4 of Huawei lab simulations, where we'll be focusing on how to implement BGP MPLS IPVPN on Huawei routers. So BGP MPLS IPVPN is a common networking technology that is commonly used on service provider networks where we have so many customers, and we need to ensure that we are separating services for all these customers. If you have two customers, you don't mix their traffic, so you need to isolate the services of all the customers using the VPN instances. So as you can see down here, we have the IP MPLS backbone, and then we have two sites. We have site 1 and site 2. So in order to isolate these services, we create VPNs on the router. That is the PE router. We have VPN 1 and then we have VPN 2. So the routing information of these two sites, site 1 and site 2, will be fully isolated in these different VPNs. And you know, this one is achieved by using the route distinguishers, which makes the route unique, and then we have the route targets that control the route import and export. So for our today's implementation, this is the topology that we'll be using to do the implementation. So we have C1, C2, C3, C4 to simulate customer sites, and then we have the MPLS backbone, which is comprised of P01, P01, and PE02, which are the provider edge routers. And then we have the provider router, only one. So this one will be our MPLS backbone, and it will be in autonomous system number 100, and will be running OSPF in this MPLS backbone. So for the objectives of this lab, the first part will be just configuring IP addresses on interfaces. Remember, that is one of the basic configuration that we need to make. And then we need to configure OSPF in S100. We are using OSPF as our IGP in S100, so we need to implement OSPF on PE01, P01, and PE02 to achieve connectivity, because at the end of the day, we need to implement BGP VPN v4, the MP-BGP peering between PE01 and PE02. So we need to ensure there is reachability between the two PEs. Then for MPLS IPVPN, we also need to do configurations of MPLS and LDP on interfaces in the MPLS backbone. So we need to enable MPLS on all routers and then configure MPLS and LDP on interfaces in our MPLS backbone. Then to isolate customer traffic, as we mentioned before, we need to do VPN configuration. So we'll create VPN instances on PE routers to ensure that we have communication, to ensure that we are isolating the services using these VPN instances. So in our lab, we have C1 has to communicate with C3. So they are sites from same customer. So we need to ensure that we have communication from C1 to C3, and then C2 and C4, they are also from the same customer. So we also need to ensure that there is communication between C2 and C4. So we'll create two VPN instances on P01 and P02. The VPN instances are not created on P routers, because remember, the P router will forward traffic based on MPLS labels. So it just does the swap operation for the MPLS labels. The fifth part of this lab will be how to configure MP-BGP between the PEs to ensure that these PE routers are able to exchange VPN routes between them. And then the second last part, which is the sixth part, is to configure BGP between the PEs and CEs. So for our PE-CE routing protocol, we've selected BGP, so we need to ensure that we are configuring BGP between the PEs and CEs. Then the last part will be to test connectivity between CEs, and we can also do a packet capture to ensure that we are able to see the labels that are being exchanged in our MPLS backbone. So for the configurations, this is part 1. So I've already prepared the configuration and configured the routers, but we will go through the configurations just to be familiar. Then we can check on the routers. So the first part is to configure IP addresses and enable MPLS on PE01, PE01 and PE02. So you can see on PE01, we are doing the naming. So we assign a name, that is PE01. Then we enable MPLS. But before you enable MPLS, you always have to configure the LSR ID. So we are using the loopback 0 as the LSR ID for all the routers in our MPLS backbone. So we configure the MPLS LSR ID, then we enable MPLS, we enable MPLS LDP. Then on interfaces, we are assigning IP addresses, enabling MPLS and also MPLS LDP. On the interface, connecting the PE01, P01 and P02. On loopback 0, we just assign IP addresses and that is it. So that is the same configuration for P01 and P02. Yeah, the basic configuration, the system name, MPLS, and then interface configurations. So on our second step, we are configuring OSPF in the MPLS backbone. It will be the IGP in our MPLS backbone. So this is also simple. You just need to enable OSPF. We are configuring OSPF process 10, and then it's always a good practice to configure the router ID. So we are using the loopback IP at the router ID. That is one of the best practices. So once you've configured OSPF, you need to configure area 0. They are all in the backbone. Then you need to advertise the networks. We are advertising the connected interface and also the loopbacks. So similar configuration on P01 and P02. So if we check on our routers, OSPF should be running and adjacent this should be up. So if we check on P01, I display OSPF peer. You can see we have two peerings, one to P01 and another one to P02. So the two PEs should be able to ping each other. As you can see, we are able to ping 3.3.3, which is the loopback 0 of PE02. So our OSPF is running. So the next part of our configuration will be to configure BGP peering between PEs. So we are doing the MBGP, the BGP VPN v4 peering between the PEs. And the configuration is also as shown. You configure BGP, the S number is 100 for our MPLS backbone. Then you need also to configure the router ID. Then we define the peerings and enable the VPN v4 peering under the IPv4 family. So this is similar configuration on P01 and P02. So we expect our peering between the two routers, the VPN v4 peering should be up. And this is a command you can use, display BGP VPN v4 all peer. You can see we have a peering to 3.3.3.3. It's in established state and AS number is 100. So we have our BGP VPN v4 peering up. So the fourth part will be, no, this one. The third part will be to which one? The fourth. The fourth part is now where we are configuring the VPN instances and binding these VPN instances on the interfaces facing the customer. So we have two VPN instances on P01 and P02. We are using the same VPN target on P01 and P02 just to ensure that they are able to exchange the routes. So we have C1 to C03 VPN, and then we have C02 to C04 VPN. So these are the two VPN that we are configuring, and you can see the route distinguisher and the VPN target that are configured for these two VRFs. So once we've configured it, we are binding them on the interfaces facing the CE routers, and then we are assigning the IP. Remember, when you bind a VPN instance, the IP will be removed. So that's why it's at this stage where I choose to configure the IP address so that I don't have to redo it. So similar configuration is done on P02. The VPN targets, as I mentioned, they are the same, just to ensure that the route exchange will be okay for the VPN v4 routes. So once you've configured the VPN instances and bind the interfaces to the CE customers, we are configuring PE-CE routing protocol, which we said it's BGP. So we configure BGP peering on P01, we are peering with C01, and then this is the VPN peering, the VPN instance peering. So we have peering to C01, and then we have a peering to C02. But remember, they are under different VPN instances, so that's why we are doing the VPN instance BGP peering. So our last part will now be configuring the CEs. So for the CE configuration, of course, we need to assign the system name, the same we did for the other routers. And then on the interfaces, we assign IP addresses, create a loopback, and then we do BGP peering. This is just normal IPv4 peering, the unicast. So we do the configurations in the respective AS numbers, and then we are importing the direct route, which will be used in testing the connectivity between the CE routers. So similar configuration is used on CE01, 002, CE03, and CE04. So you can see the configurations as highlighted. So once we've done these configurations, we can now go and test that there is route exchange between the PE and CEs. So if we do on, I will first display IP VPN instance, just to ensure that yes, we have the two VPN instances configured. On P02, we have the same. If I do display IP VPN instance, we have two VPN instances configured. And if you display current configuration, no, I need to start with P01. Display current configuration interface gig 0/0/0. You can see the VPN instance is bind to C01 to C03. I can do display, so these customer routes will not be in our public routing table. If you check the public routing table, you realize there are no routes from the customers because yeah, they are in the VPN instance. They are land under VRF. So we have a routing table for each VPN instance, and they are not in the public routing table. So if I do display BGP VPN v4 all peer, we can see the peerings to the CEs is up, C01, C02. The peering is up. On P02, similarly, we can do the same. Display BGP VPN v4 all peer. We have the peerings to C03 and C04. So our peering is up. How about the route exchange? First, we can do display IP routing table and then VPN instance. This one, C01, C02, just to confirm that we are learning the routes from the CE. As you can see, we are able to get this route 6.6.6. No, 4.4.4, which we are learning via eBGP, and the next hop is this router. You can also just display BGP VPN v4 all routing table, and this one will give you the routes learned via the VRF. So we have these routes that we are learning via this VRF C02 to Z04. Then we have this route that we are learning from C01 to C03. So if you check on P01, we expect to be also learning the VPN routes. Display BGP VPN v4 all routing table. You are able to get the routes for both the VRFs in the respective VPN instances. So if we check C01, In display IP routing table, we are now learning the routes from C03. Remember, 4.4.4 is on C03, so we are learning this route from the PE, and we are able to ping it. If we check on C02, I do display IP routing table, we are able to learn this 5.5.5 from our PE router, and we can ping 5.5.5. It's also reachable. So we have achieved the objective of the lab by implementing the BGP, MPLS, IPVPN on this backbone network. So for the labels, if I were to do a packet capture here while I'm doing a ping, we can see clearly that I've started my packet capture, then I will go on C01. So on C01, I can ping 4.4 just so that we generate some traffic, and then this one I will filter ICMP just to make, because we have so many OSPF packet, but we only need ICMP. So you only have need these only. These are really filtering. Try again to filter ICMP packets. Enter. Thing is not. Let me close this and open a new window. So I will do a packet capture here. Then we only need ICMP. Let's see if we are able to do. Yeah, this one will work. So on C01, I will do a ping, and then we can see the packets. If you check the ICMP packets, we can clearly see that we are having labels assigned on these packets, and we have the inner label and the outer label. So this clearly demonstrates that we have MPLS working in our network, and we are able to assign the customer label and the outer label. So one thing that you need to pay attention to when you are doing the MPLS IPVPN implementation is that you should never forget to configure MPLS and LDP, because if you don't configure MPLS and LDP on any of the interfaces, the routes and even the traffic will not be able to flow on our IP MPLS backbone. So for example, if I were to go and on this interface facing on P01, if I remove MPLS and LDP, I do so currently we have MPLS and LDP. So if I do undo MPLS, of course it will remove also MPLS LDP, and then we again try to ping. You realize our ping is not going through, because remember MPLS and LDP work hand in hand. So you need to remember to check and verify that you have configured MPLS and MPLS LDP on all interfaces in your MPLS backbone. So thank you for watching, guys, and please remember to subscribe to our channel and to check other interesting videos in our channel. Thank you.